I'm Anil Kumar. Welcome to my series on functions. Now let us discuss how rate of change of a function is related with the function itself. Now based on that, I've taken up a graph and related questions. This is very important and it can be seen in most of the test papers. I would like you to pause the video, copy this question, answer, and then look into my suggestions. Now let's try to understand. The question here is, consider the given graph of rate of change of a function to answer following questions. So that's the rate of change of a function's graph. Questions here are, question number 1, the function is increasing at which point? So I've not given interval here. We are only considering points. You need to identify the point where the function is increasing. Question 2. The function has turning point at which of these given points? And question number 3 is the function has local minimum at which point? Now if there are more than one answer, you identify the best. Okay. So let's begin solving them, and I hope you must have got your answers. Okay. So the very first one here is the function is increasing at which point? Now remember, this graph is not of the function. It is of rate of change of the function, right? So from here, we have to think about the function and then answer. So I hope you did that before answering. Otherwise, this is also a good time to pause and correct your answers. Okay, so let's look into the solution. The function is increasing. So if you're analyzing the rate of change of a function, in that case, the function is increasing means that rate of change is positive, correct? That is what it means. So it is increasing all throughout these intervals. So we have to look for a point within these intervals. -3 is on the left side, so it is not increasing. X equals to -1 is somewhere here, and it falls in this interval. So that is definitely a point where the function will be increasing, correct? Now this is kind of a different point, so that is our best answer, correct? Question number 2. Now in this case, function has a turning point at which place? Now how do you identify the turning points? In a rate of change, if there is a turning point on the function, then the rate of change will be 0, right? So these are actually the turning points of the function. So any one of these could be in your answer. So let's check. 0 is there. So that is the turning point of the function. So if the function has a turning point, then the rate of change at that particular point is going to be 0, right? So this will be horizontal, correct? So that will be 0. So that is how you identify the turning points of the function. Is that clear to you? Correct? Now, question number 3. The function has local minimum at. So local minimum will be at the turning point, right? So will be at turning points. So that is for sure. Okay. Now which one? So we have, in this case, 3 turning points. Local minimum basically means that the function will be decreasing and then increasing to give you the local minimum, correct? Decreasing means rate of change is negative and increasing means rate of change is positive. So the point where the rate of change changes from negative to positive, right? So this is the point. At this point, we should have local minimum, correct? So that should be your answer. You're looking for x equals to 2, which is option D. You get the idea. So that is how we have to answer these questions, correct? Now here is a question for you. Now you got all the information about the function. Now the question for you is, let's say question 4, sketch graph of related function. correct? So the rate of change graph is of degree 3, is a cubic function. So what do you expect? So graph of this should be quartic, correct? So I'd like you to sketch the graph of the function now from here, right? So I hope you, with this information, that is not difficult. So you can actually now pause the video once again and sketch the graph of the quartic function, which could have rate of change as shown here. Perfect. Now let me give you the solution also here. So from here we know these turning points are local maximum and minimums, right? So if the rate of change is negative, that means the function was decreasing. So let me mark the turning point as this. This is one turning point. Now this is minimum since it is going from negative to positive. In this particular case, it is going from negative to positive, and so the graph will be negative to positive, means here it is negative, just as this point. So this is also a local minimum, right? So we'll take local minimum here also. Here we are going from positive to negative, so that should be a local maximum, correct? Now if you connect these points, you actually get your solution, which is a quartic function kind of like this, right? So it's not that beautiful a graph, but I hope it gives you the concept, right? So kind of like this. So that is how we'll get the graph of the function itself. Perfect. Now I think everything matches, right? So that should help you to understand the given situation. So in this particular case, we actually had two local minimums. There was also a local minimum at x equals to -2, right? So that is how you should be answering these types of questions. I hope that makes sense. Now this question is very important even for the students who are doing calculus, right? So we are basically analyzing the derivative of the function and we are trying to figure out what the function could have been like, right? So I hope that makes sense and helps you. Feel free to share my videos with your friends, and if you have comments, just put them there. And your questions are always welcome. They always help me to come up with something better. Thanks for watching and all the best.